Let's take a look and review the slope of a line and parallel and perpendicular slopes. During this course, you will use your algebra tools to learn more about shapes. One of your algebraic tools that can be used to learn about the relationship of lines is slope. So let's review what you know about slope. The slope of a line is the ratio of the change in y to the change in x. If we are looking at our picture to the lower right, we can see that the change in y is our up and down movement, and the change in x is our left and right movement. Okay. The slope indicates both how steep the line is in its direction upward or downward, and left to right. So most of us have seen this equation before on the right, but we're not really looking at it in the way in which we've been taught. So our slope formula is, recall, y2 minus y1, the vertical change, over x2 minus x1, or our horizontal change. So in this we are placing our coordinates, the y's, so 5 and 3, and over our x's, 3 and -2. That is where our slope of 2/5 comes from, is this subtraction within the ratio. So now lines that point upward from left to right, point upward in the x direction of left to right, have positive slopes. Lines that point downward from left to right have a negative slope. A horizontal line has a 0 slope, while a vertical line has a undefined slope. And let's take a look what that really means. So our horizontal line has a 0 slope. That means that the slope of this line occurs because I am taking 0, or my vertical change ends up being 0, and with the horizontal change being some number. So I'm taking 0, dividing it by a number, and ending up with 0. Now our vertical line has undefined slope because what happens when I'm solving that fraction is there's some number, or my vertical change ends up being a number, but my horizontal change never happens. And we know that in math you cannot divide by 0. So that is why we say the slope is undefined, because the way in which we define multiplication and division does not have a definition, or the definition doesn't work when we throw 0 into the mix. Okay. The slope of a line is denoted by the letter m, and in our equation for slope-intercept form, y equals mx plus b, we can find the slope right there. So one way to calculate the slope of a line is to pick 2 points on the line and draw the slope triangle that we see over here. Determine the change in y and the change in x. Now, in determining change in y and change in x, if I'm on a coordinate grid, you're simply just counting left to right and up or down. Also, when you're finding and then graphing the slope of a line, you need to be sure that your slope result, negative or positive, its value is based on its direction, meaning if the line is pointing down and to the right, then you know that if your slope, you know that your answer needs to be negative. If it's pointing up and to the left, your ratio, your fraction, your m, needs to have a positive value. So you should have a negative result after you do the subtraction. Parallel lines lie in the same plane. So a flat surface, your piece of paper is flat, and you can draw these lines on it. They never intersect. They will never cross. They will go around the world many times over and never cross. They have the same steepness and therefore grow at the same rate. Well, all steepness and rate are other fancy ways to say slope. So the steepness of a line, or the rate at which a line increases, is also just the slope of that line. And parallel lines are going to have the same. Now, on the other hand, perpendicular lines intersect, and in fact they intersect at a right angle. So for example, in our picture, lines M and N and lines M and L are perpendicular, okay? And the reason we know this is because we're being told so in our picture with this little box in the corner that indicates the 90-degree angle. I've also circled lines L and M to denote that they are parallel, but what will happen as we get further along in this course is that if two lines are parallel, they will have parallel line markings on them. They'll have little triangles indicating that the two lines point in the same direction and have the same rate. Now, earlier I mentioned that steepness and same rate means slope, so now slopes of parallel lines are the same. It's being defined for us again. That means when I'm done counting or figuring out what the slope is, I should have the same fraction. So for instance, the slope here of line L is 1, 2, 3, 4 movement left or right, and 2 movement up. So my change in y is 2, my change in x is 4. The slope of N, 1, 2, 3, 4. Its rise, 2. So again, I get 2 over 4. So this means same slope. Their fractions, or your answer after you find your change in y over change in x, should be the same. Now the slopes of perpendicular lines are what are called opposite reciprocals. This phrase is not going away. You will hear this over and over and over again. So for example, if one slope is 4 over 5, the opposite reciprocal of 4/5. So reciprocal means I'm going to take the numerator and turn it into the denominator. Flip it. Opposite means I'm going to go from positive to negative or negative to positive. So let's look in our picture. Our slope of line M is 1, 2, 3, negative 4, I'm counting down, and 2 to the right. The slopes of L and N we've already found. We know that they are 2 over 4. Okay, not equal, but opposite reciprocals. So we're going to use slopes of parallel lines and slopes of perpendicular lines to actually help us identify specific shapes based upon what the sides of the shapes are doing and how they are intersecting each other.